All right, let's practice drawing some ray diagrams. The first ones we're going to do here are for concave mirrors. Remember, a concave mirror has a positive focus, which means the focus is in the front, and remember the center of curvature is twice the distance beyond that. And notice that with all these, we start with an object that's beyond the center of curvature. Now the object is at the center of curvature, between the center and the focus, at the focus, and inside the focus. We'll find that the image is different depending on where the object is. So let's start with the first one, and let's remember all we're going to need to do really for these, for most of them, is ray number 1 and ray number 2. So ray number 1 starts at the tip, remember, and goes parallel and then through the focus. So we're going to go parallel to the mirror, and then little trick, hold your pencil there and just rotate your straight edge, and it gets reflected through the focus. And remember, there's a virtual ray back here behind the reflected ray. So there's ray number 1. Ray number 2 is just the opposite. Instead of parallel and through the focus, now we're going to go through the focus and then parallel. So here we go, from the tip through the focus to the mirror, and then it gets reflected parallel to the principal axis, virtual ray behind the reflected ray. And there's our ray diagram, and now we're just looking for where the rays intersect, and that's at this point here. So there's our intersection point. Since we started the rays at the tip, the image of the tip is formed where they intersect. And remember that the base of the arrow always stays on the principal axis. So the image that is formed looks something like that. We got to answer these questions about each one of these, whether it's upright or inverted, enlarged or reduced, real or virtual. Well, I can look at this one. If I did it correctly, the first thing we want to do is real or virtual. Notice the virtual rays diverge, and these are real rays that are intersecting. Therefore, the image is real, and since it's real, we know it has to be inverted. They always are, and this one is inverted. Magnified and reduced, or enlarged and reduced, I'm not quite so concerned about. In this one we can tell because the image is definitely smaller than the object, so we're going to say reduced on that one. They won't always be that way, and I will tell you there are some times that you can't really tell on these. So on your own, I want you to do these two, number 2 and number 3. With both of these, you can use ray number 1 and ray number 2. Should be fairly simple, fairly straightforward. With these, you should also end up with a real inverted image on both of them. Number 2, the image is really, it's neither enlarged or reduced. Depending on how you draw it, you may get an image that is slightly off, but the image should be formed right underneath it. If you don't get that, that's okay. I don't really care about this question for this one. This one you should get an enlarged image, but it's still real and inverted, and it'll be out here, but still ray number 1 and ray number 2 for those. So pause the video real quick and see if you can do those. Alright, we're back. Here's what I drew for number 2. Ray number 1, parallel and through the focus. Number 2, through the focus and parallel. Image is formed here. It's a real image. The virtual rays do not intersect. Real and inverted, and it's neither enlarged nor reduced. It's actually the same size. Again, yours may be here or somewhere over here if you didn't draw your lines quite right, and that's okay. No matter where the image is, you should definitely know that it's real and inverted. And then with number 3, images back here, it's enlarged actually, but still real and inverted. All right, let's look at number 4. Number 4, you might have noticed, if you tried to do it, doesn't actually work very well. Number 1 works, so we can draw ray number 1. That's simple. Parallel and through the focus, virtual ray. But you'll notice ray number 2 doesn't work well because number 2 is supposed to go through the focus, which is here. Through the focus to the mirror is not possible. We could do one of two things. We could do ray number 3, which goes through the center of curvature, but if we go through the center of curvature, that requires that we extend the mirror up here, which we could do, that's fine. But I want to do an alternate ray, a ray number 4, if you will. You don't need to memorize this ray, and for that matter, you don't really even need to memorize exactly how this ray diagram is done. But This is just to show you what you get in a concave mirror. So ray number 4 starts from the tip and it goes straight to the vertex of the mirror, and at that point the vertex of the mirror is the mirror itself is at a 90-degree angle to the principal axis, which means the principal axis is actually the normal, which means this thing obeys the law of reflection, so this angle of incidence has to be equal to this angle of reflection, which is actually always the case in these. So it's got to come out at exactly the same angle it came in at, and there it is, virtual ray. And you'll notice if you drew it right that these lines are parallel to each other. They never intersect. These don't and these don't, therefore we get no image out of this. We get no image. We can't do any of this. It's not real, it's not virtual, it's not enlarged. We get nothing. And here's what we're talking about here. When you get a concave mirror, let's see if we can see this. At some point, I don't know if we can even do it. So we get an image there, you get an image, and at some point you get just kind of nothingness. And then you see something, but it's not really there. You can't get an image from it. You can't see it very well on this. Get your makeup mirror if you have one. Get your mom's makeup mirror and look at that. You'll notice that as you bring the mirror closer to your face, at some point you get this big blob of nothingness. You see light, but it doesn't form an image, and that's at this point. That's when your face is at the focus of the mirror. And then when we move inside the focus, something else interesting happens. Once again, we can do ray number 1 here. Here's ray number 1. Virtual ray. Ray number 2 we can't do because now the focus is back behind us. That's even more impossible. So we're going to do our alternate ray again that goes from the tip to the vertex and then comes out at the same angle. Something like this. Virtual ray. And I'm going to need to make these longer. This one is what you get when you're actually using a makeup mirror for its intended purpose. Notice that back here our virtual rays intersect, and so our image actually looks something like this, quite large. And they're virtual rays that are intersecting. Notice the real rays do not intersect, they come out. Your eyes are seeing these rays diverging from one another, and it automatically traces them back to a point where they would have intersected if they were actually back here. Remember that they're not. So it's a virtual image, it's definitely enlarged, and it's upright. Since it's virtual, it has to be upright. This is what you see when you look at that big giant image of your giant pimple on your face in your makeup mirror, and this is what's happening then. You can only do that if your face is inside the focus, closer to the mirror than the focus. If that's the case, you'll get a big virtual image which is made in your mind. If you're at the focus, you get no image. If you're outside the focus, if you're outside the focus if you're outside the focus, you get real inverted images. You're upside down. All right, so that's drawing ray diagrams in a concave mirror. Backside of convex, the difference with convex is that we have a negative focus, which means the focus is back here in the back. Once again, the image is simply moving, changing locations. If the focus was here in the front, you're just moving it from one place to another. Let's see what happens here. We're going to actually use on these, on all of them, on all convex mirrors, use ray number 1 and ray number 3. Number 2 works, but it can be confusing. So let's start with number 1. Parallel and then through the focus. So there's parallel. The focus, remember, is not here on this side. It's on the other side. So we take our straight edge, make a line to the focus, but remember the real ray doesn't get here because the light rays can't get through the mirror. So the real ray is going to reflect. Remember, this is a diverging mirror. The light rays diverge away from each other. It reflects this way, and it's actually the virtual ray that goes through the focus. That's our ray number 1 for a convex mirror, right? And then we're not doing ray number 2. You could if you wanted to, but it can be confusing. I'm going to do ray number 3, which goes through the center of curvature. This is the center of curvature here. So you got to start at the tip, look at the center, and we're going to start on that line. But again, the real ray doesn't go past here. It gets to the mirror and it gets reflected back on itself. So it comes back, reflects back on itself, and this is now a reflected ray. Virtual ray goes behind the reflected ray. like so. And there's our ray number 3. So notice now real rays do not intersect, virtual rays do. There's the image of our arrow, very small. Remember, the base is always on the principal axis, and the tip, the image of the tip, is wherever the intersection is. Virtual rays intersect, so we have a virtual image. It is upright, and it's definitely reduced. The image is smaller than the object. If you do the rest of these, 2, 3, 4, and 5, I want you to try to do those real quick. They all work the same way as this. You'll use ray number 1 and ray number 3. Draw them the way I've done here. The image will slightly change locations and it'll change size a little bit, but these, you should get all 3 of these on every single one. You should get a virtual, upright, reduced image on every single one. And that's how to draw ray diagrams for curved mirrors.